The power of 0. What, Miss Britton, I hear you ask? I'm glad you asked, students. Here we go. So, if I have a power of 0, the rule is anything to the power of 0. So if I've got a, and I raise it to the power of 0, that is going to equal 1. Now, some students will just learn that, and they will apply that, and they'll get questions right, and that's fine. But I want to prove to you why, in fact, that is actually true. So let's look at a problem where I will end up with 0 in the index. So if I have, for example, a cubed, and I divide it by a cubed, we know from the second law that we did on division that when I have division, I'm going to subtract these indices. So I know when I solve this problem, I'm going to get a to the 3 minus 3, which equals a to the 0. And I know what some of you are thinking. You're thinking, hang on, Miss Britton, that is not 1. And I'm going to say to you, hold your horses. Let me show you one more thing. If I set this out in expanded form, check out what happens. So if I go a times a times a, that's a cubed, divided by a times a times a, and then I go ahead and I do my cancelling. Remember, when we cancel, we're actually dividing the top and the bottom by the same thing. So if I divide by a, I get 1. Divide by a divided by a is 1. Do it again. Divide by a, I get 1. Divide by a, I get 1. So 1 in the top, 1 in the bottom. I can go again because I've got another a here and another a here. So I'm going to divide by a, I get 1. And a divided by a is indeed 1. So what have I got here? Well, when I look at this particular answer, I've got 1 times 1 times 1, which is 1, over 1 times 1 times 1. Or, can we just call that 1? So what I've got here now are two different mathematical equations, and the question part is the same, but notice that the answer part looks different. If you're happy that I can state, and let me change colours, I'm going to go to this colour. I can state that this is the same as this. Hopefully you're happy with that. A cubed divided by a cubed can also look like this. It means the same thing. So I can put this equal to this. Well, in the same token, that means I can put the answers equal to each other. So that means that a to the power of 0 must equal 1. Because if a to the power of 0 equals this, and 1 equals this, we've said that these two things are equal. So I must be able to say that the answers are also equal. So then we say, therefore, a to the power of 0 does in fact equal 1. So the reason we end up with 1 is because it's better seen when we do expanded form. You can see here that everything cancels out and we end up with the answer 1. So hopefully that explains to you and proves to you why the power of 0 is so cool. Thank you.